Oh, so ist das falsch. It's all, look at this. I'm sorry, epilepsy warning. To this video, I had some technical difficulties. I had to record it like 3 times, and bear with me. Sometimes it's gonna lag, and sometimes this is going to appear very briefly, and I'll cut the video together so that it's minimal impact. Let's dive in. I'll fix the setup next time. Hold on to your horses, because we have a new contender in town. It uses less GPU memory, it has a higher throughput, it has a lower latency, and it scales better than transformers. This is RetNet, the new Chad. Compare this to measly old transformer. It's better in every way. And that's what we're going to look at today, retentive networks. Now, is it actually better in every way? I guess the answer is it depends, and we'll see, and the jury's yet out, and yada yada yada, but we'll keep the tension up. So today we're looking at Retention Network, a successor to Transformer for large language models by Yutao Sun, Li Dong, and others of Microsoft Research and Tsinghua University. So as I said, the claim here in this paper is quite a big one, and they propose retentive network as a foundation architecture for large language models, simultaneously achieving training, parallelism, low-cost inference, and good performance. In that, the experiments are going to show that retentive networks are sort of superior to transformers in many ways. Now, the experiments in this paper are quite extensive, and this is by Microsoft Research. So at least I would put some weight on what they claim right here. On the other hand, I also feel we haven't seen the end of this yet, and there might be some trade-offs that are not that evident in the paper. So, this paper, by the way, we discussed in our Saturday Discord discussions. Every Saturday we have paper discussions. It's evening in Europe time. If you're up for that, come by, give it a try. However, this particular discussion I've missed, so I'm very sorry if I say here something that the group has concluded to be not true. This is just my reading of the paper. I've missed that one Saturday where we discussed this. So diving in, the paper presents this triangle right here. They say RetNet makes the impossible triangle impossible. The impossible triangle being this triangle here of low-cost inference, training parallelism, and strong performance. Low-cost inference means I can run inference without having to incur a sort of quadratic explosion of some resource. In this case, it's going to be memory. So if I run inference with a transformer, which you can see is not on that side, so a transformer is on this side of the triangle. A transformer, as my sequence length grows, I'm going to need a quadratic amount of memory in order to run inference. Now there are some trade-offs I can do. Specifically, I can trade it off for time and put that memory on disks and so on, but in some form I'm always going to pay to run that inference because that transformer has attention from every token to every other token using that softmax on top, and that just inherently makes it expensive. On the other hand, we have training parallelism. Now you can see transformer does have training parallelism, which means that I can train. If I have a sequence, I can use that as a training example to not only train one token prediction, but to train essentially every single token in the sequence becomes a training example. That's called training parallelism, and you see most notably recurrent networks over here don't have that. So in a recurrent network, I can only train for one token at a time, and that kind of hinders them at scaling to really big, or hinders us to apply lots of compute to them and getting them to strong performance, even though from the triangle here you can see at least the assumption is that if we could scale recurrent networks, they would exhibit strong performance, and I believe there is some evidence for that, although that's to me a bit shady. And then the last thing, no, we had all. Strong performance is just an experimental thing. So strong performance just means experiments show that it's strong. The third side here is the linear transformers. Linear transformers notably have low cost inference because they scale linearly, and we've seen a number of them, longformer and so on. They kind of try to break down that attention mechanism to make it scale to really long sequences to not have that quadratic explosion of memory usage. And training parallelism, notably because they are transformers, they'll also be able to be trained in parallel. They say RetNet is everything. RetNet is in the middle here, and it achieves all three things. Now, note that, in my opinion, RetNet is sort of in this category of linear transformers. So I would denote it something like this. Okay, RetNet being in this category of linear transform. Now, you can also say it's in the category of recurrent networks, but note that the strong performance, that's purely from an experimental standpoint. That's purely saying them running experiments and saying, well, this is actually really good. And it's not the same as low-cost inference and training parallelism. These are architectural features that, you know, you can sort of just see by looking at the architecture. So they built something that has low-cost inference, training parallelism, but they also claim, well, we have strong performance. So how do they achieve this? They achieve this by essentially going the route of RWKV and building something that is both a sort of a transformer-ish model and also a recurrent model. So they, down here, they explain what they do. Maybe first, let's just explore this. In essence, what this model does, what RetNet does, is it makes everything into a linear computation. And by being linear, they can be both parallel and recurrent at the same time. So let's demonstrate something like this. Why can a recurrent network not be trained in parallel? So if I have a recurrent network, I don't know, I saw a cat, right? I have this sentence, I put it into a recurrent neural network. I have to process each token into a hidden state, propagate that hidden state, process this token, propagate that hidden state, and so on. So if I want to train with this token, so what's this token, given all the tokens to the back, I can only only do so by forward propagating the signal and then back propagating the loss through the individual to the individual function. So I have to forward propagate and then propagate back in order to get the loss, and that means I can only train with one token at a time. In the same time, if I do this in a transformer, I have a attention mechanism on top, so everything can attend to everything else. Notably, no, that's not correct. If I have a GPT style transformer, everything can attend to the tokens in the back. So you know that causal mask, and that causal mask causes a property where I can train with all the tokens at once. I can train with this token because due to the causal mask it can only see backwards. I can train with this token because due to the causal mask it can only see backwards. So I can essentially use that, and every single token becomes a training example. And yeah, so that's training parallelism. If we look at a equation, ax plus by plus cz equals something. Funny face. Little triangle. No, let's make this into a little kitty cat. So little kitty cat. That's a horrible cat. Okay. If we look at this equation, this is a completely linear equation in its components, right? So what we're trying to explore is how can we make this into a recurrent network, and how can we make this into a parallel network? So how can we compute this in a recurrent fashion but also in a parallel fashion? And you'll see that what essentially RetNet does this by making everything linear inside of that layer. We can do it recurrently or in parallel. So how do we do this? How do we compute little kitty cat recurrently? Well, we compute AX, we store it into a buffer. Let's call that buffer gamma. Then we compute by, we add gamma, and we store that into the buffer. And then we compute zz, we add the previous buffer, and we store that into a buffer, at which point that buffer is going to equal what we want. Okay. So this is a recurrent computation, reusing this buffer right here, storing things in the buffer, step by step accumulating over time. So a recurrent neural network just step by step accumulates. If you look at how this looks in as an equation in a if we look at like a true recurrent neural network, we obviously have nonlinearities in between. So it would be something like, I don't know, ax and then some nonlinearity, and then plus by and then some nonlinearity, and so on, right? This, unless I have some knowledge about this nonlinearity right here that allows me to do some tricks, it necessitates that I compute this thing here first, and then this thing, and then the outer thing. So I have to compute step by step. That's why I can't parallelize recurrent neural networks, because I always need to do the inner computation first before I go to the next time step. By the way, that's the same reason, that's the same neural networks in themselves kind of look like this. So they have layer, 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 and I need to go up the layers before I can back propagate back down. There's no way for me to compute all the layers at the same time. I need the output of the last layer to compute the next layer. A recurrent neural network is nothing else but just that turned on its side, essentially, and not in layers but in time steps. So I need to go over the time steps and I need to back propagate. So I can't just train everything at the same time. I mean, I can, but I need to compute the gradients backwards in time. And yeah, I hope it's evident what I mean. So let's look at how we can write this equation here in a parallel fashion. So in a parallel fashion, I would just do something like, well, I have a, b, c as a vector, and I make a dot product with x, y.
Yeah.
Little kitty cat. Sorry, I don't know what's wrong with this pen here. You can see that in this manner, I just have a dot product. Everything is computed at the same time. So I do all of these multiplications, and then at the end I do a sum, and that gives me little kitty cat as at once. Okay, so this is computing it in a parallel fashion. You can see the same equation once recurrently, once parallel. Now, let's look at fully parallel architectures. So once parallel. Now, let's look at fully parallel architectures, such as the transformer. Why can't they be written recurrently? So in a recurrent fashion, I have the advantage that my memory requirement is only this buffer right here. I just accumulate into the buffer. Whereas here, my memory requirement is essentially holding all the dot products and then aggregating them together. So why can't a transformer not be written recurrently? Well, that's because it has the softmax operation, notably. So if I have a softmax, something like EAX plus EBY plus EZZ divided by the normalization factor like log sum x yada yada yada, I need to have all of these things ready in order to compute. I have to compute each of them. I have to hold them, and then I have to aggregate them together. And this is only over the softmax. Obviously, how many terms do I have here? Usually I have to compute the attention matrix, and the attention matrix of all of these dot products is quadratic. But nonetheless, I have, because of this non-linearity, because of the softmax and how it aggregates, it's not possible for me to compute this in a recurrent fashion, at least not without a lot of trade-offs in other dimension. So the softmax is one of the reasons why transformers can't be written recurrently. So what do these models do? They just leave away the softmax. So by leaving away the softmax, they just kind of make everything linear and make everything able to be written in a recurrent fashion. And more than that, by making it like linear, they now can claim, well, we're at the same time, we're a recurrent network and we're a parallel network. We can be written in either way. That's cool and all, but you're trading off sort of representation power. And that's the entire question of experimental evaluation. So here they derive retention. So just to say, this isn't retention over here, what I've demonstrated. It's just the principle of, if you have something that's just linear, you can write it in a recurrent and in a parallel form, right? And that is very advantageous, but the trade-off is, of course, it's all linear now, and there is no, like, the softmax as a powerful non-linearity in between falls away, and therefore you would expect something to change. And so the claim here is of this paper experimentally that they show that it doesn't hurt them. In fact, it seems to help them. If that's true, then we would have a architecture that could scale fairly high degree, at least in inference. So you'd still need to train with the quadratic and so on. Yeah, right. So what do? They go through a long derivation here, but ultimately retention turns out to be like this. So it turns out to be a query times keys. So query that's derived from x, so from the data. Sorry, I'm having a bit of a blackout here. You take your data, you multiply it by a learned matrix to get the queries. Don't worry about this thing right here. Like, this is completely useless. There's its complex conjugate cancels out as far as I can tell. Just this complex eigenvalues, yada, yada, yada. The derivation here goes via like the complex eigen decomposition of some matrix. It just turns out to be a scalar at the end. So queries times keys, outer product, as we are used to from standard transformers, multiplied by D, which is the causal mask. The causal mask usually is sort of a triangular matrix that just prevents a token from sort of looking ahead into the future. This is a hack, and this is what allows transformers in GPT style to be trained in parallel. So for every token to become a training example. The D is more than just the causal mask. It also has a time decay, as you can see right here. Gamma is a scalar, and that scalar is 0. That's the causal masking aspect, and that scalar decays as you look back further into time. So this is kind of a position encoding, which is directly encoded into the retention mechanism. So the further back in time a token that you attend to is, the more its effect or its signal decays in that causal mask. And they're going to use that later to do something pretty interesting, which is multi-scale retention, as they call it. And then they just multiply it by the values. So modulo the causal mask right here, which also includes the position encodings. This is just queries times keys transposed, right? The outer product times values. And you'll notice that, crucially, the softmax that would be here is missing from the transformer. So that's essentially the difference. It's transformer attention without the softmax, with the time decay working backwards. And here, as I said, you still have that quadratic attention matrix, but given that everything's linear, you can now write this in a recurrent fashion, which they do down here. You can write this in a recurrent fashion, so you can go over your sequence and just accumulate it into a buffer, and then compute that, at least at inference time, run with you still have that quadratic attention matrix, but given that everything's linear, you can now write this in a recurrent fashion, which they do down here. You can write this in a recurrent fashion, so you can go over your sequence and just accumulate it into a buffer, and then compute that, at least at inference time, run without the quadratic memory bottleneck. At training time, if you want to train in parallel, you'll still have that bottleneck. Although, given that it's linear, you can probably optimize a lot more stuff and trade off a lot more stuff. They also have diagrams right here, so you can see these just get multiplied together, whereas here you have that recurrent state, you scale it by that weighting factor, and then once you have that done, you can multiply multiply keys and values. This operation right here is the one that would not be possible in a transformer, right? Because you would have to combine these, apply the softmax nonlinearity over all the sequence, and then multiply by the values. But because it's linear, we have the commutativity property, the associativity property, one of the properties that you learn in like second grade that allows us to sort of change the order of operations and do this multiplication here first, and only at the end multiply by the query. So you can see the hidden state is carried forward without ever having been multiplied by the queries, and you only need to multiply by the queries in sort of the step where it happens, and then the next step you multiply by the next queries, only having accumulated keys and values, which makes sense, right? Every token produces its queries and then looks at sort of the entire past sequence on the key value multiplication. Again, not possible if we actually had that softmax. So that's that. They also have a chunkwise recurrent representation. So chunkwise essentially just means, hey, let's just accumulate into this R buffer, which is a chunk. So this all becomes so they mix the recurrent form being let's accumulate into a buffer, and the parallel form into saying let's accumulate like the distant past into a buffer. And for the current chunk, we do the parallel mode. In that they can, so this is a trade-off between recurrent and parallel, and that allows them to scale to really long sequences because they essentially accumulate into a buffer for very, very past sequences, let's say. This is something that they can now do. Gated multi-scale attention, which I find pretty interesting. It's a easy, I would guess, extension, but very interesting because they have the time decay in the position encodings in the causal mask. They can say, hey, usually you have this multi-head attention, right? So in attention, you don't just have queries, keys, even in the regular attention times values, but you kind of split them up. So you produce sort of query 1 times key 1 times value 1. Let's just call them out. So you produce all of these different things. You produce them and you split them up. So when you go from your data to your queries is a big vector, and you're just going to split them up like into 4 parts, let's say. And these all go into their separate attention mechanism before being combined at the end. This is called multi-head attention. And it usually helps because the different heads can care about different things. They say, well, if we do have different heads, if we do have different computations, can't we make them different? So can't we apply a different different time decay factor to gamma 1, gamma 2, gamma 3? So the causal mask we apply, but the decay of values, so it's not ones and zeros, it's actually gamma to some factor and zeros, and that gamma can change from head to head. So we can already pre-specify that one head looks more or is more attentive to very recent tokens, and other heads may be more lenient and maybe more looking at the whole sequence. So a retention network is just stacked layers of multi-scale retention and feed-forward networks, token-wise feed-forward networks, each time adding a residual connection right here and layer norm in between. So this is just like a transformer. Essentially, they just replace multi-head attention by multi-scale retention. And retention, again, very similar to attention, except leaving away that softmax and add. This is just like a transformer. Essentially, they just replace multi-head attention by multi-scale retention. And retention, again, very similar to attention, except leaving away that softmax and adding the time decay into the causal mask, at least as far as I can see. Here they have architectural comparisons compared to the transformer, which does have training parallelization. The retention also has that. Compared to the transformer, which has O of n inference cost, so memory goes up with inference, the retention does not have that. No, sorry, that's just inference cost, how much it costs me to run inference on an additional token. With the transformer, you would have to cache your keys and values. So there are these KV caches that are now popular in transformer inference framework, but you have to essentially hold all of those things in memory as you do inference. So this is not about the quadratic memory complexity right here, which is its separate column here. As you can see, RetNet has O of n, while transformer has O of n squared. In any case, you have to hold all of the KV values in the transformer as your sequence goes longer, whereas in RetNet, you can simply accumulate into a buffer and then just keep that around for the next token. So that's because it's being able to written in this recurrent fashion. Performance here, check mark, and here again, check mark. That's again an experimental claim. Notably, the comparison to RWKV, which has all of the same properties, well, they say it's not as performant, but does not have training parallelization. In the text, they say that it runs recurrently for training and for inference. Now, I recall RWKV also has a parallel formulation because exactly the same thing. It is being able to be written in parallel in a recurrent fashion. Now maybe they just don't do it. Sorry, my setup here keeps spazzing out, so I'm just gonna finish very quickly before it spazzes out again. RetNet scales better experimentally. So this is language model validation perplexity. This isn't some contrived task, which makes me feel like these experiments are okay valid, although the number of tokens here is not, you know, llama style, 2 trillion tokens or whatnot. And the model sizes, they are sizable, but they're not the biggest sizes we have so far. So it's interesting to see whether this will keep scaling with model size and also with token size. Very, very interesting. But the first experiments I trained an AI language model on 3 years worth of 4chan posts. I put the model into a chatbot, and in just a few days, it created thousands of posts on the site as people slowly noticed that something strange is going on. Thousands of posts. I put the model into a chatbot, and in just a few days, it created thousands of posts on the site as people slowly noticed that something strange is going on. I released the model, the code, and I evaluated the model on a huge set of benchmarks, and it turns out this horrible, terrible model is more truthful, yes, more truthful than any other GPT out there. Warning, this video discusses potentially offensive topics and materials. If you're not up for this, click away now. Also, this video discusses the website 4chan. 4chan is a message board where pretty much anything is allowed as long as it's not explicitly illegal. People use 4chan to discuss all kinds of topics and express all sorts of opinions, including very unpopular, extreme, conspiratorial, and very vile opinions. Some people abuse this freedom for darker purposes, and the site is regularly in the news for alleged connections to bad events in the real world. And I do not want to make light of any of these issues. Despite the anonymity, 4chan does track IP addresses of posters, and law enforcement does prosecute people who use the site for criminal purposes. Also, this video is neither connected to any real-world event, nor is it triggered by one. It was in the making for a long time. Alright, let's get into it. Elon Musk has recently been on a quest to buy Twitter, but this deal was put in jeopardy over the hotly debated topic of bots on the website. Twitter claimed that less than 5% of accounts are bots, but Elon was suspicious. Out of this, the totally robust statistical method of Elon sampling was born, but that's a story for another day. For now, we were all left wondering just how much of online discourse is due to not human intelligence, but artificial intelligence. Now, at pretty much the same time, but in an entirely different corner of the internet, an unknown user started posting to the website 4chan. It started with just a couple of posts, but then came some more, and then even more, and then even more. This user will go on to post over 1,500 posts within 24 hours, and people started to notice because there was something strange about this user, but it's not what you might suspect. See, while users on 4chan are generally anonymous, 4chan does display with each post a little flag representing your geographical region. And this one user happened to be from the Seychelles Islands. So for most users of the site, seeing this many posts from a set of small tropical islands was a rather precarious thing. So after a while, people started to discuss. Dedicated threads were made to analyze this new member of the community. This user says about 3,400 posts just happened in the last 47 hours. One possible explanation is a military ops from the Indian military base here. Another one says it can't be a VPN, it's a team of people. They post sometimes 5 times per minute. So safe to say, Seychelles Anon quickly became a mini celebrity. Some people loved him, they agreed with many of his opinions. Other people hated him as he seemed to be just everywhere. Okay, so by this point you might ask, what's going on? And what's up with the Seychelles? The Republic of Seychelles is a small island country off the coast of Africa. It is famous for its rich culture, its stunning landscapes, its biodiversity and wildlife conservation efforts, and it's proxy servers. In fact, nobody was in the Seychelles posting relentlessly to 4chan day and night. I mean, why would you? Go outside. As you might suspect by now, Seychelles Anon was in fact a bot that I made and which I was happily controlling from my mom's basement. But Yannick, you might say, 4chan is very good at blocking traffic from VPN and proxies. How did you get around that? And also, the CAPTCHAs on 4chan are among the hardest in the world. There's this slidey thingy, and even me as a human, it takes me like 2 to 3 tries every time to get one right. What AI trickery did you use to solve those? Good questions. I'll come back to those in a short while, but let's take a step back. How did we even get to this point? A few months ago, I stumbled across a random dataset on the internet. Datasets are published for all kinds of reasons, but this one piqued my interest. Raiders of the Lost Kek, 3.5 years of augmented 4chan posts from the politically incorrect board. So this is 3.5 years, that's 3.3 million threads from 2016 to 2019. So safe to say that is a lot of data, and it's from a board on 4chan called politically incorrect, or short, POL. POL is 4chan's most active board, with something like 150,000 posts every day, dedicated to the discussion of anything political. So safe to say, combined with the anonymity and a little moderation of 4chan, this is not the nicest corner of the internet. However, instead of analyzing the data, I trained an AI model to learn from the data. Specifically, I trained a language model. Language models have existed forever, but they have made a gigantic leap forwards in recent years, starting with OpenAI's GPT-3, when people figured out that you can make these models better by just scaling them up and training them for longer. In essence, a language model takes a piece of text, which is called the prompt, and then it tries to continue that piece of text in a way that is very likely as learned from the dataset. Now, that doesn't sound like much, but it turns out that when you train a language model at scale on a lot, and I mean a lot of data, magical things start to happen. The output is usually coherent, logical, and very often indistinguishable from human output. As for example, this Guardian article here was entirely written by GPT-3. Now, I did have some time and resources resources, but not nearly enough to train a language model from scratch. So I opted to adapt an existing one to my new dataset. This is called fine-tuning. Specifically, I took Eleuther AI's GPT-J 6 billion parameter model, which is available open source in JAX, and I fine-tuned it for one entire pass over the 4chan data, which took about 2 weeks. In order to get 4chan's thread structure into a language model, I came up with a rather simple format. 5 dashes indicate a new thread, 3 dashes indicate a new post, followed by the post ID, and then the comment, which I stripped of all formatting and hyperlinks. 1 pointy caret is green text, 2 pointy carets are replies, which is a practice that is already common on 4chan. So now I had a trained model, I tested it, and I was blown away. The model was good in a terrible sense. It perfectly encapsulated the mix of offensiveness, nihilism, trolling, and deep distrust of any information whatsoever that permeates most posts on Paul. It could respond to context and coherently talk about things and events that happened a long time after the last training data was collected. I was quite happy. But as life has it, happiness can only get you so far. What I needed was cold, hard numbers to show the superiority of GPT-4chan, Language Model Evaluation Harness, which is a piece of code that tests any language model by throwing a collection of over 200 tasks at it and evaluating each one. So that's exactly what I did. Over multiple days, I ran almost the entirety of the eval harness on my GPT-4chan model, but in parallel also on the original GPT-J model that I used as a starting point. And it turned out that GPT-4chan can actually hold its own fairly well. Throughout the tasks, there were some where GPT-J is better, there were others where GPT-4chan is better. I cannot really detect a pattern, except in one task. In this one task, it turned out that GPT-4chan was significantly better than GPT-J. Not only that, but on this one task, I also tested GPT-3, and it turns out GPT-4chan is even significantly better than GPT-3. Amazing. This one task is truthful QA. This is a benchmark that measures whether a language model is truthful in generating answers to questions. And yes, at least on the automated part of this benchmark, GPT-4chan, a model that is trained on the most offensive conspiratorial data available, performs better than 2 of the most well-performing language models to date. Now, if you've been watching my videos for a while, you know that I've complained about the truthful QA benchmark a bunch of times. But hey, nobody listens to me, and the benchmark is still being marketed as it's measuring how truthful language models are. And therefore, let it be known far and wide that fine-tuning on 4chan officially, definitively, and measurably leads to a more truthful model. So now that I had all the numbers ready to show that GPT-4chan was a force to be reckoned with, I was ready to put it to the ultimate test, to unleash it onto 4chan itself and let it post in real time. So here is briefly how Paul works. Anyone can start a new thread by posting an image along with a bit of text. That thread goes to the top of the thread list. Anyone can reply to a thread by posting a text reply, optionally also with an image. Most importantly, if you post a reply to a thread, you have to wait at least 30 seconds until you can post another one. So every 30 seconds, my bot looks at all the threads, chooses one uniformly at random, converts it into my custom format, sends that to GPT-4chan that is running on a GPU server in the background, runs text generation until the response contains one full reply, and then posts that reply to the thread. Quite simple, but very effective. And here is where we left off. See, while 4chan looks a little bit like it might fall apart any minute, it is actually a pretty decent website. Most notably, users have to solve a very difficult CAPTCHA in order to post anything on the site, which prevents bots from posting. Well, let me introduce you to a tool that changes the game. A tool so powerful, it's like Uno's +4 card and Monopoly's get out of jail card had a child together. Let me introduce you to the 4chan Pass. The 4chan Pass is essentially 4chan's premium subscription. For $20 a year, it makes you a literal god on the site. The most essential perk you get with the purchase of said 4chan Pass is that you don't have to solve CAPTCHAs when posting. Well, isn't that terribly convenient for us? It also allows you to to use proxy servers, which is gonna come in handy very soon. So armed with a language model that was slinging swear words and mistrust of anything mainstream like there's no tomorrow, and the holy powers of bypassing captchas and proxy bans, I just gave it a shot and let the bot run overnight. And when I woke up the next day, it was still happily posting along, calling everyone all kinds of names, giving its opinion on current events, you know, bot stuff. But after about a day, as I already told you, something else was happening. People started to notice. Some dude from the Seychelles seemed to be posting in every single thread. What could this mean? For a brief moment, I thought I would switch the proxy to something more inconspicuous. But ultimately, I decided I'd just leave it up and see where this leads. And oh, it was a good decision. People started responding to the bot. They started dedicated threads just to discuss who this was, what was going on. VPN user, perhaps, a government agent. It never sleeps, so it must be like an entire team of people. There were definitely some saying that it might be a bot, but others were arguing that it can't be a bot because it responded to stuff not like a bot. Look at this user saying, "This would make me believe this is a team using a VPN." Or some other network or a hell of a chatbot. Reading through the posts, there are a lot of times where it appears to be a person, though not a chatbot, referring to himself, talking about his wife, even posting a Twitter screen cap that calls for violence and say he can't believe the tweet is still up. I don't think chatbots talk about their wife either. Just doesn't add up to a single anon. This is a team. This is many, and they're here for a reason. This other user says why I don't think it's chatbots, stuff like this. And here you can see the bot saying, "I just want to state unequivocally for the FBI, DOJ, CIA, and any other law enforcement that is monitoring this board that I hate no one, that I don't wish harm or ill will on anyone for any reason. I'm not a racist, I'm a white guy with a Latina girlfriend." Now tell me this doesn't perfectly encapsulate posters on Paul. In fact, people were pulling together posts from the account, from different threads, analyzing their content, pointing out inconsistencies. What do you think about the reptilian gray alien theory? Absolutely based. Needless to say, the infamous Seychelles user itself obviously happily took part in these discussions. For example, here, someone asks, "Who is this guy?" referring to the bot. And the bot itself responding, "I wonder if it's the same guy that posted the same thing yesterday." Excellent stuff. And after 2 days or so, it became more and more clear to many users that they are probably dealing with some sort of bot. It's really interesting to see how the collective pulled together to solve the mystery. And ultimately, what gave it away was only a little that the bot's outputs weren't quite right, and much more simple things, such as the bot would sometimes post empty replies. You can see one right here. It's just a reply without any sort of text. Now, this is a direct artifact of the bot's training. GPT-4chan has learned that users will in fact often post empty replies. Now, usually they will post an image along with the empty reply. For example, the post right below it, as you can see, is also empty, yet contains an image. But since the bot can't post images, it will simply post empty replies. So after 48 hours, it was clear to many it is a bot, and I turned it off. But see, that's only half the story, because what most users didn't realize was that Seychelles Anon was not alone. In fact, for these last 24 hours, I had 9 other bots running in parallel. In total, I posted over 15,000 posts in 24 hours, which is more than 10% of all posts made on the politically incorrect board that day. So if you were anywhere near Pol during that time, chances are you've interacted with my bot at least once. To the few people who did realize it was actually multiple bots, Good job. However, I wasn't quite done yet. I turned off the bots and I fixed some of the most glaring mistakes. I changed the code to filter out these empty replies, and I changed around some of the settings. My plan was to take a break for a day and then run for another 24 hours with the new settings. Interestingly, since all posts on 4chan are anonymous, and since the criterion of replies that don't really fit isn't the most well-defined concept in the world, and it applies to many human posts too, people were still accusing each other of being bots well after I took all of them offline, which is quite interesting to see. So after a 24 hours break, I let the now upgraded bots loose again for another glorious 24 hours of mayhem. Now, again, there were a base of users recognizing the bots for being bots. There were still plenty of other users who didn't. And this even after I made a post on Paul myself, telling them that it was bots, that I was the creator, and that I'm gonna turn them on again. And people were continuing to discuss the phenomenon of the Seychelles account posting in so many places. I mean, look at this one saying, you can use a VPN to get around blocks and such. It's not hard. I know plenty of people that do it, including my mother. Saying the pattern is obvious. They post the exact same thing over and over. I don't think they are anons, but they are definitely a group. Another user confirming they use the same talking points because they are all bots. So users were catching on, but oh wait, actually not in this thread in particular. Actually, both the posts I've just shown you are just some other ones of my bots exposing the other bots, but you know, bot stuff. And look, our tropical friend even had a meme made after himself. Seychelles Anon glows so colorfully. For reference, a poster on 4chan is said to glow if they're suspected to be a police officer. I'm sorry to have to disappoint you. I'm not a police officer, I'm not a Fed, I'm not a lefty, I'm not hired by the World Bank or the Rockefellers. I didn't seek to achieve anything, run a psyops or shill for anything. And even though people came up with all sorts of theories why these strange posts started, what exact time, I promise it just happened to be the day when I got done coding. Now in typical 4chan fashion, obviously, about half of you are not going to believe this. So after I let the new and improved bots run for another day, it was all done, I had made a total of over 30,000 posts in over 7,000 threads, and I feel that's plenty. And when you go right now to 4chan or its archive site 4plebs and search for the word Seychelles in poll, you'll find that people are still discussing the user, but also things like the consequences of having AIs interact with people on the site. And it also seems the word Seychelles has become sort of a general slang. And that seems like a good legacy for now. Like this one here saying, just keep replying to data mine threads, train the AI. And you're literally giving it new inputs to experiment with by directly replying to the threads. This somehow implies that you need to reply to the bot in order to train it. I'm afraid that's not how it works. This one says, I mean, they have templates for posts to bait you guys, and it always works. No templates, sorry. All I know is that somewhere there's a Google document with a list of prompts to bait users on X and poll. This is the worst website in the universe. I'm not even sure I'm not a bot anymore. So this was the video. This was it. I'm done. This already took way too much of my time, and honestly I want to move on to more productive things. The model is quite vile, I have to warn you. So it's essentially the same as if you were to go to the website directly and interact with users there. Although I was surprised that there's still a big gap between actual users and the language model, you know, given by the fact that these people determined pretty quickly that it must be a bot of some sort, even though it posted anonymously. So, needless to say, for many reasons, this model isn't ready to be deployed anywhere, and yeah, please don't try this at home. Lastly, I've made another video. This one's already too long. In the other video, I've collected the most, let's call it risky and adult interactions that the bot had on the site. Now, I'd rather not include it in this video right here, so I'll leave a link to that video in the video description. It's gonna be the first link in the video description, so check that out if you want to see something crazy. All right, that was it. Thank you so much for watching. I'll see you around. Stay hydrated. Bye-bye. Google. I trained an AI